Hey everybody, I'm Chris Dagher. I'm the CEO and CTO of QTex AI, and I'm going to talk today about designing purpose-built AI applications beyond just LLMs and ChatGPT. I want to start with talking about why chat sucks as an interface. Everybody knows this. ChatGPT, it's just a blank slate, right? And you can pretty much type anything you want into there and it'll tell you what you want to know, or sometimes what it thinks you want to know. The problem is, this is an empty slate. So the solution, obviously, is Claude. Kidding. It's the same problem, just a different skin. So the real problem with chat is that if a tool can do anything, it doesn't tell you anything, and nobody knows how to use it. So it's really a design problem. It's not a user problem. It's not your fault that you don't know how to use ChatGPT. It's my fault that you don't know how to use ChatGPT. So everybody probably has seen this at some point, right? You've gone through a support tree, a chat bot on some website, trying to get a refund for something or get customer support, and it says, oh, I'm sorry, I don't know how to help you with that. Ask again, but in a different way, or contact support at this phone number. It's like, well, why is the chat bot even there? Is it even useful? The problem with this is that it's really built on the last 2 decades of natural language processing research, where it's just keywords, trying to figure out basic intent, and all it can do is try its best to navigate through a tree. So people are used to this kind of a chat interface, which is very rigid and very limited, and then they're used to it failing. So now we have 2 problems. Nobody knows how to use chat, and nobody trusts chat. Don't tell that to college students because they trust it too much. So the bottom line here is that chat isn't actually a product. It's really just an API with a text box. And it kind of feels that way, right? It doesn't feel like it's a real product. Obviously, ChatGPT and Anthropic's Claude have like new stuff now where they can do like interactive diagrams and things like that. But overall, it just feels like a text box, right? So I'll talk more about how to get around that later. But I want to start with what an LLM wrapper is. And to get to that, really, like, what is an LLM? It's really just sophisticated autocomplete. An LLM doesn't actually know anything in the same way that you do and I do, right? Like, humans have this super complex brain on the order of like 10 to, oh, I'm going to get this number wrong. It's like 10 to the 13 or 10 to the 23 neurons, somewhere on that scale. It's one of those, I know. On something like ChatGPT, we're talking like 1 trillion parameters, which is essentially a neuron. And 1 trillion is, what, 10 to the 9? 10 to the 12? 9 is billion, 12 is trillion. So we're talking like 10 orders of magnitude different. I'm pretty sure it's 10 to the 23 is the human brain. So because it's just autocomplete, it's confident by design, and it's right most of the time. But when it's wrong, it's very hard to predict that. And it takes an expert to know when it's wrong. So I'm going to check my notes here. The important thing, if it doesn't matter when it's wrong, it's a wrapper. So what does the architecture of this look like, though, from a product perspective? Well, the user types in a question, and then the prompt is literally the product. The entire product is the system prompt. It's that thing where you've probably all seen the joke of somebody telling ChatGPT or Claude, you are an expert software engineer, you do this, this, and this, you try different things, blah, 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 whatever, just like telling it its personality, essentially. That's the system prompt. That's the entire product for a wrapper. So then it goes to the LLM, which has no domain-specific logic, no domain-specific knowledge, because it's been trained on the entirety of the internet and every single book ever. So even though it knows everything, the problem with knowing everything is that it doesn't know what part of everything to focus on. And then it just gives that back to the user. So the problem with this is that anyone can copy a prompt. And in a lot of cases, you can actually extract the system prompt by asking nicely, which probably doesn't seem like a good way to protect your product, does it? So the barrier to entry with something like this is basically 0, because in minutes or hours, especially with modern AI software generation tools and like website generation tools, In literally 5-10 minutes, maybe an hour if it's your first time doing it, you can have a chat app stood up and live on the internet with a cool system prompt so anyone can use it. But again, there's zero differentiation, there's zero moat. The barrier to entry for somebody else doing this is basically zero. So in high stakes domains, think legal, engineering, science, medicine, those kinds of things. Usually right isn't a product. In fact, it's a liability, and these companies end up having to buy a lot of insurance. Take my word for it. I mean, think about this for a second. If you're a doctor, actually, I think that's not the next slide. 2 slides from now. Yeah, anyway. AI, most people think about it as ChatGPT, right? Who thinks ChatGPT is AI? Like, when they hear AI, who thinks ChatGPT or Claude? Fewer hands than I expected. I mean, it's fair. Most people do, right? We say AI. Every marketing thing has AI in it, and everybody immediately thinks, oh, ChatGPT or Claude or whatever, something like that. But it's actually huge. And thinking this is essentially like thinking the internet is Google, which is obviously false, like demonstrably false. So there are a lot of different types of AI. There are classifiers that can tell if an email is spam, embeddings that are useful for search, recommendation, deduplication, constraint solvers that can be used for scheduling, logistics, your UPS truck figuring out what the route is going to be, graph systems for fraud detection, like when your card gets flagged because you bought something overseas and you forgot to tell your bank that you were traveling. Computer vision, like Amazon warehouses use tons of computer vision to figure out where packages need to go and if something fell off a conveyor belt. And simulation models. So my PhD started in physics-informed neural networks and robotics. So we used a lot of AI, physics-informed AI models in order to actually determine how to refine and train the AI. And these are some of the examples. This is not a complete list, but AI is huge, way beyond ChatGPT. ChatGPT is essentially just like that kid in the 4th grade band who got the tuba, right? Way too loud. And nobody can hear anything else. So when do we use an LLM? I just gave you some examples of when not to use an LLM, but an LLM is really great for being flexible, for reasoning, for natural language where you're not sure what the user might put in and you need it as a gate to figure out what to do next. But it's really bad for precision. Ask ChatGPT to count how many R's are in strawberry. I think it'll say 5. That number changes, but it never gets it right, even though it actually probably could. Determinism, because these are probability models, everything is literally just a probability on a bell curve. We're talking like a trillion bell curves smushed together, but it's still just a bell curve. And so at the end of the day, if you want it to be deterministic and always with the same input, the same output, it's not going to be able to do that. It's going to be terrible. And then the last thing is really structured lookups. And like, this really is when close is not good enough, right? When you're saying, oh, well, these 2 medications are close, but they have significantly different side effects. What if your doctor was like, hey, I'm giving you a script for this, and the pharmacist gave you a script for something else, and you said, wait, that's different. And they're like, yeah, it's close enough. Would you accept that? You guys can talk. No, you wouldn't accept that. You'd say, absolutely not. Give me the right medication. So think of an LLM as knowing how to solve a problem or how to approach a problem, but then the actual tools as the things that do the real work. And in the technical terminology, that's called the agent harness, which is like the collection of tools that do the thing.
So like the R's in strawberry, so like a vision model, though, would not get that wrong, or do they still have problems?
It might still get that wrong. So vision models a lot of times end up, some of the newer ones don't do this, but most of them actually convert the images into a text embedding, and then they just process it the same way as they would text. So not necessarily OCR, where they're trying to pick out the text or the characters, but because it's we use a tokenization process, which is essentially, we don't look at every single character. On average, a token is like 4 characters. So we're looking at the next 4 characters, and we're just trying to predict those, which is why it can't count strawberry. Like, that's technically speaking, LLMs can run code now, so they could just say, hey, for all the characters in strawberry, count the number of R's and then return that. But for some reason, nobody's done that yet. I don't know why. Anyway, the bottom line with LLMs is that you wouldn't really trust a general contractor to wire your house because they can hold a wire, right? Or they can strip a wire. You'd want an actual electrician to do it because they know what they're doing and they know how to not do it wrong. And when your house inevitably burns down because the general contractor did it wrong, well, you can sue them, but you still don't have a house. Anyway, I want to talk about RAG and why pizza goes on glue. I'm guessing none of you know what I'm referring to. Okay, it's literally what it sounds like. In 2022, Google Bard, before it was called Gemini, very confidently, at the top of Google search, this was like when AI overviews in Google were first coming out, it suggested to somebody that they put non-toxic glue in their pizza sauce to make the cheese slide off, or to prevent the cheese from sliding off. Obviously, this is false. Obviously. Except that the LLM does not know the difference between satire and a serious comment. It literally pulled that from a 2013 Reddit thread. So RAG, now that you all have had a laugh, is literally retrieval augmented generation. We retrieve some piece of information, we give it to the AI model, the LLM, and it generates something based on that retrieved information. But obviously, you need to retrieve the right information. You need to retrieve authoritative information. And the fact that this happened isn't a random error. This is a systemic thing that's baked into the model and was a result of poor labeling. Because instead of a human saying, this is actually not a good source of truth, the LLM was like, this is a source of truth. I'm going to use that because the pizza is having, the cheese is falling off. So I don't know how many of you are product people, but think about that. If your product put that as an actual suggestion, that's terrifying. That's like a lawsuit waiting to happen. Anyway.
Can't open my mouth.
Exactly. Yeah. There was actually a satirical Reddit thread after that of somebody who said they did put glue in their pizza. Of course. The internet is a terrible place. Anyway. I kind of already mentioned this, but the problem really is that the AI retrieved garbage data from a source that it thought was reliable and authoritative because it hadn't been told any different. It wasn't told, this is not a real source of information, don't use it. It just said, there's a source of information, it must be reputable. And very confidently, as it is trained to do, spat it back out. And this is the slide I thought was 2 slides ahead, but was actually like apparently 6. The difference here is really a doctor who just looks at you and says, I don't know, this is probably what's wrong with you. Which, unless Dr. House is your physician, it's probably not a good thing. Versus a doctor who looks at your chart and says, okay, I've looked at the chart, I've read what I need to know, this is probably what's wrong. Obviously, I think we would all prefer the second kind of doctor. So, quick plug for my company. Part of the technology that we do is we do retrieval first, generation second, and then we actually specifically only pull information from known authoritative domains. So that way, we don't have to deal with satirical Reddit threads telling people to, in our industry, short every wire on a circuit board together because the electricity will know where to go. That's actually something that an engineer one time said, and I about died. Yeah. So in a nutshell, what our system does is, instead of guessing, it uses the information that was given to it to look up recommendations for parts, to find authoritative sources of truth from real documentation, and then it reasons based on that to put the pieces together and figure out what to do next. And I'll show you guys what our system looks like in a little bit. So now that I've explained what is not a moat, a system prompt, and what RAG is, which, even though I didn't say it, kind of is really the foundation of all enterprise AI because you need to have some authoritative ground source of truth. What is a moat in AI? You're the moat. This guy. Everybody go up to him afterwards. No, the domain expert is the moat. You look like a domain expert. You have very smart glasses.
It's really probably about the information that it has access to, like you said, like the RAG. So the difference between an AI agent that is based on somebody who studied marketing for 2 weeks and built the agent versus an AI agent that does marketing based on someone that has 20 years of marketing experience. That kind of, the difference between that garbage and like authoritative.
Exactly, yeah. Oh, wow, that was, anyway. Yeah, that's pretty much exactly the difference. So a lot of hype goes on in Silicon Valley, right? Because these guys who know how to code or know how to prompt AI can create a new product in a day, 10 new products in a day. But that's not hard. If you haven't done it before, it sounds hard. But if you like actually play with AI to build products, it's not hard. It's hard to build a good product that knows what it's doing because it doesn't have the experience. So essentially, talented generalists, the Silicon Valley guys, who just are like, I have this idea, I'm going to go do a bunch of research. I'm going to task Claude, not ChatGPT, recall, Claude, with figuring out the market for this and telling me everything I need to know about it. It's probably going to fail because that person has no idea what they're doing. They may have spent 2 weeks doing it, but if somebody who spent 20 years doing something decides, I'm actually going to go solve that, they'll probably know what to do, and it's going to be better. The problem is that if you only spend 2 weeks, you don't actually know how something goes wrong. I'll speak from engineering because that's my background. To anybody who spends 2 weeks in engineering, and I've seen enough freshman students to know this, even seniors who seem to think this, I took statics, I can do everything. I know how to 3D print, I can do everything. No, you cannot. It takes an expert to actually know when the math is wrong, how to check your math, because a lot of times, even though math doesn't lie, you can do the wrong math. Whether your assumptions are wrong, because a lot of times in engineering, if you have the wrong assumptions going into solving a problem, it doesn't matter how you solve the problem, because you've done it wrong. So the domain experts are really the difference, and they're truly the moat between somebody who just spent 2 weeks learning this and somebody who spent 20 years doing it and knows exactly how it's going to fail. What happens when a marketing campaign goes wrong? How do you fix it? How do you prevent a marketing campaign from going wrong? How do you prevent a bridge from collapsing? Okay, if the bridge already collapsed, you got a big problem. And the AI model is going to be like, oh my God, I'm so sorry. Because every time, right, how many times have you said, oh, actually that's incorrect to ChatGPT? And it's been like, oh no, you're absolutely right. I am wrong. It was very confidently wrong, and then it's very confidently right about being wrong, only because you pointed it out. So the real moat is the domain expert. And for a concrete example of this, somebody who just started designing electronics would have absolutely no idea to check for a power regulator being undersized in a IoT device for a microcontroller. But in our product, we ingrained the information into the AI model and into the tool set and the agent harness so that it was able to look at these components and say, okay, you've got this linear regulator powering this microcontroller. Under normal circumstances, it's fine. The linear regulator can supply up to 300 milliamps of current, and under nominal conditions, the microcontroller draws 250 milliamps, so you're fine. Except under peak Wi-Fi load, when it draws 478 milliamps, let's call it 500, all of a sudden, you've got a 200 milliamp deficit. Most of you look like parents, so it's essentially like when your kid overdrafts their account. Exactly. Yeah. All of a sudden, they're going to be like, oh no, what do I do? So in practice, in a product, what happens in a hardware product is that this doesn't necessarily get caught in testing, and you might ship a product, you might ship 10,000 units of this thing, and then all of a sudden, 6 months later, your customers call you up and they're like, hey, my thermostat all of a sudden just like randomly turns off midway through the day. I don't know why. And then another customer calls and says the same thing, and then you got 5,000 calls saying that same exact thing, and it's because somebody who just spent 2 weeks figuring out what to do doesn't actually know what to check for. It takes a domain expert who actually spent time and has seen these errors and seen them literally blow up in some cases. The number of things I've accidentally blown up in a lab are non-zero. it takes that kind of a person to know what's actually going to fail.
So, and sorry, you said that's built into your.
Yes.
So how is that not just part of the system prompt? Be sure to check for milliamp overages.
Yeah. So the way that it's not just baked into a system prompt is essentially by putting required checks. So like an agent cannot proceed until it has performed a certain type of check. You can like strictly enforce that beyond just like a system prompt, beyond just an LLM, in the actual structure of the agent.
I'm also a bit lost maybe. Are you saying I could not upload this into latest ChatGPT or Claude web interface and ask it where this would fail?
It's totally possible, and it might be right. But if you're putting $2 million on the line, do you want to gamble with that? If you have a laptop that you're shipping, or if you're Dell and you're shipping a new laptop, and you've got not $2 million, $20 million on the line, do you want to trust ChatGPT that has no specialization?
Wait, what is the purpose of the AI in this? I mean, this is hardware. Someone needs to build it and finally test it.
Yes. Sorry, I got a little bit ahead of myself.
Sorry.
But
I think the point is, yeah, you can put it in the system prompt if you have the domain expertise to think ahead to put it in the system prompt, right?
But you can't because
It goes-
it's not deterministic.
yeah, it goes well beyond the system prompt because of the non-determinism. You can't exactly predict what the AI model is going to do. You have to put specific rigid checks in a lot of cases. And it's not just engineering. I'm speaking about engineering because that's my background and that's what my company does. But in marketing, for example, you might say, okay, we need to check this for color blindness, like whether or not it's going to work, like somebody's going to be able to tell the text from the background if they're colorblind. An LLM is going to have absolutely no idea how to do that. And actually, a concrete example of why don't I just put this into ChatGPT, Boise Fry Company on St. Patrick's Day sending out that email that they immediately were like, oh my God, we're so sorry, referencing the potato famine, because ChatGPT very confidently was like, yeah, this is fine.
That was AI that it did.
Yeah, ChatGPT wrote that. So
What did it say?
it sent something about the potato famine and St. Patrick's Day, and that's probably not something. We do have plenty of potatoes in Idaho, but that's probably not something you want to send out. And that's just plain ChatGPT doing that. Whereas a specific tool that is designed around domain expertise, somebody with experience will know. Well, they'll know how to check for those things, and so they'll build it into the tool. But having those checks is really the differentiator. It's totally possible. I know people who upload hardware designs to ChatGPT and ask, hey, what's wrong with this? And it catches some things, but there are also a lot of things it doesn't catch. And to give a concrete example, in my own domain, we tested a laptop motherboard in our system, which, for those of you who don't know, electrical engineers can upload their designs and will find design problems before they become an expensive manufacturing mistake. A laptop motherboard is way too complicated to give to ChatGPT just because there are too many connections, there are too many details, too many things to keep track of. How many people have seen ChatGPT or Claude hit the tool use limit, where it's called too many tools and now it's failed, or you have to try again, or you have to tell it to continue? Yeah? Okay. That's exactly why it can't do that, in addition to not having specific tools to enforce certain checks and find problems. Wow, we just covered like 3 slides without, anyway. So the bottom line really is that architecture of an AI system is your domain expertise, your knowledge turned into an executable pipeline that's reproducible. So I'm an engineer. I know exactly how to design a circuit board and what to check for because I've set things on fire, blown them up. I've had expensive mistakes, manufacturing mistakes, products that are in the real world that people are like, hey, this is not working. Why is it not working? I want my money back. And through that, we knew how to build our own product that knows what to look for. But the problem with domain expertise is that you can become a perfectionist. You can overbuild, over-engineer. So think about it like this. You want it to be perfect. You want your product to be perfect because you know exactly what it needs to do. And it's almost there, but it just needs to be a little bit better, just a tiny bit. Okay, now we got that. Now it needs to be even just a tiny bit better because it would be so much nicer if it did this one other thing. you're never going to ship. You're never going to have any profits or revenue because nobody's going to use your product because you didn't release it. So you have to balance actually saying, okay, this is good enough with knowing what is good enough and making sure that things work. And you need to test it. A lot of people just say, I'm going to build it, I'm going to ship it, and then we'll fix it when it breaks. But in high-risk fields like engineering and medicine and science and legal practices, that doesn't work. You need to know how it's going to break in advance so you can plan for that and correct it. So now I will give you a really good example from my own company. This is not me trying to pitch to you guys, but just from my own company, what does purpose-built AI actually look like? So one way that you do this with a wrapper is you write a system prompt telling it, be very careful, catch all of the errors. I always see people, Claude has skills. I always see people who are complaining that Claude skipped step 2 in the skill and went from step 1 to step 3 and then did the rest of the skill, but step 2 was really important. Okay, so a system prompt probably doesn't work. And this is where you, like I said, you hope it works properly and then you just ship it and you'll fix it later maybe. Whereas a purpose-built system, it knows what correct looks like because it's built into the system. It is physically baked in through the code. It checks against correct. And then it just uses something like an LLM to synthesize the things that are right and the things that are wrong within whatever it's been doing. That's the difference. It knows that it's right or it knows that it's wrong. And worst case, it's a little bit overcautious. So this is actually a screenshot from our product. And you might notice that there is no chat box. There's a button that says discuss this, but the main interface, and this is just like part of it, but it has no text box. There's no text input. It is as non-AI as it can possibly be because that is what the engineers who are our customers want. Essentially, you upload your file and you hit go. You hit a button that says do the thing for me. And it knows what to do and it does the thing. And then because we try to find problems before they become a mistake, in production, we say, oh, hey, here's a problem. Here's another problem. Here are citations back to all of the documentation telling you why this is a problem. And then the engineer can go and verify. So this is really the solution to just a text box and an infinite scrolling canvas. Essentially, yeah, text boxes suck. Make a button that's just the do it button. That's how I like to think of it. Is if they're yeah.
Tech-wise, what is the stack behind it? Like, is it semantic kernel or LangChain or like how which?
We use a mix of LangChain, LangGraph, our own proprietary database architecture, and some of our own other models that we built internally, on top of some other off-the-shelf cloud stuff.
Do you mind sharing how you monetize it? Like, is it per user?
Yeah, it's per user.
Like token amount or?
So we do a consumption-based price per user.
A complex plan is more hard than a small plan?
Yeah. Yeah, if you're uploading a motherboard for a laptop versus a like a thing that needs to blink some LEDs, like a remote for the light strip that you bought to put on your patio, those are wildly different levels of complexity, and we're not going to charge a lot of money for the remote control for the light strip, but we are going to charge more for the motherboard because we're adding a lot of value there. Yeah. Monetization is a whole other thing, though. I mean, that's like it's hard to figure out how to monetize something and how to price it. You could ask ChatGPT, but you might not get the right answer.
A question on this. So your product obviously is the interface that drives the agent stuff, but you also have the database of the industry-specific knowledge as well that you can use context. So there's not like a customer and there's a scoping phase where you're getting their data to put it in there. Like you are providing the data. Okay.
Yeah, we provide the data. There is a way actually within our product for customers to provide their own data, and then we put it into our index in like a siloed manner so that it's just for for that customer. But yeah, our product is really, in the interface, I could care less about it personally. As long as there's a button that says go, the interface doesn't matter. It has to be designed around engineering and the customer, and in this case it is. And the interface is not so much the product. It's really the agent stack that's doing the thing. But yeah. So some other examples of this. Midjourney has the /imagine command. That's a specific purpose-built image generator. compared to, well, I guess maybe Google Nano Banana would be a better example now. It's a specific image model for generating images, whereas Claude has no image generation capability, but it can probably draw you some really nice ASCII art. It can. It can do that, but it's not as good as something like Nano Banana, which is a much better image model. GitHub Copilot is also a good example of like a LLM-based product for a specific type of customer. It's just code generation, but it's really built around serving developers and software engineers. Or something like medical imaging AI. This is a totally not LLM application. Medical imaging is really complicated, and it takes a lot of training for doctors to learn how to do it correctly, how to like read images. But you can also train AI models. That's actually in some AI classes in universities, they'll give you a sample data set and they'll say, hey, train a model to detect pneumonia based on chest x-rays. It's a toy example, but think about how many chest x-rays a doctor has to look at and they might miss something. But an AI model is much faster than a doctor, and if it's 99% as good, the risk is reasonably balanced, and now that doctor can serve 100 times more patients. Yes, some might get missed, but some already get missed. So it's really a balance of risk. But yeah, compare something like that to just typing into, does WebMD have an LLM yet? They must. Yeah, I mean, everybody's typed something into WebMD and then it's been like, you have cancer, right? But okay, no, you have a sinus infection. Yeah.
If you have an AI or an LLM generate something, and then you want to check for correctness, do you want to use a different AI to check that? Because the original error came from that one, so how would it know from? So for example, let's say I have Midjourney generate a person, but then I have a vision model check that there aren't 6 fingers. And those are two different AI models, and you're having a different one check the first one. Or is there a way to get the same model to check itself? Or is that kind of impossible because it didn't know in the first place?
There is, that's an active field of research, and it's a huge problem and a huge topic. There are ways to get a model to check itself. Typically, though, within a single session or conversation, it's not going to be very effective at checking itself because the context will pretty much be poisoned by what it just did. But I would not feel comfortable giving you a blanket answer because there's a very nuanced answer to it, and it's a very long answer. But there are ways to do it. So the last thing I have, and I think, oh wow, I'm ahead of actually where I was planning to be. I want to leave you guys with a few things, then we can just do some Q&A, I guess. How do you tell hype from actual real tech? And there are pretty much 3 questions that I'll give you guys to tell the difference. The first is, what happens when it's wrong? If the answer is, it doesn't matter, it's probably a wrapper, which is generally hype. Now, I'm not saying taking a picture of, I'm not saying taking a picture of your food and asking this app how many calories it is isn't useful, but ChatGPT can also do that, so you probably shouldn't subscribe to an app that does that. Yeah.
Can you take a step back real quick and just describe one more time what a wrapper is? Because what you just demonstrated from your company, in my mind, is a wrapper.
Okay.
And you're selling it as, what did you call it? Product specific? No.
Yeah, it's product specific AI or like industry specific AI.
But underlying, you're not training your own AI.
Correct.
In my mind, that is a wrapper.
Okay.
Are you seeing that different? Has that changed? Because my mind might be very outdated. But every time you say wrapper, it's like, yeah, that's what you just showed. But you seem to think it's not what you just showed.
Sure.
Can you just clarify what a wrapper is?
Yeah.
Give an example for a wrapper.
A wrapper is essentially if I took ChatGPT and I said, well, I'll use the food calories example. If I took ChatGPT and I said, you're an expert nutritionist, your job is to look at a picture of food and tell me how many calories are in it based on the ingredients and what you can see. And then
Calling the ChatGPT web interface a wrapper.
Well, no, I mean, I can take the ChatGPT API. Anyone can.
Right.
And it's still called ChatGPT. Like they used to use the terminology GPT, whatever, and now they use ChatGPT, whatever. Now they're on like ChatGPT 5.4 or something. But it's still, I mean, yes, the ChatGPT web interface is in itself a wrapper, but so is any other app that only gives it a system prompt and doesn't do anything else. So the difference between what that is and what my company does is we actually build specific tool sets that force the AI model, which is specifically only used for like reasoning and looking at specific pieces of information that our retrieval algorithms pull. So like we look at a data sheet, a technical data sheet, which is a long PDF for a specific microchip, and then the LLM queries it. Our systems, which we built from scratch, pull information out of that, return it to the LLM. It does some reasoning, and then it calls a bunch of other tools that we built. So it's not simply just a system prompt that is saying, you're an expert, be super careful, do this, do that. There are physical checks baked in that the AI model cannot bypass. It physically has to do certain things, and if it doesn't, then we go back and force it to do those. So there's, yeah.
Okay, that just clarifies things.
Yeah, no, that's,
Because
I'm
most wrappers that I know have all of this. They have a dashboard, they have anti-prompts, they have settings, they have import features. Like they wrap everything, but it's still underneath. They just wrap it. That's a good word.
Yeah, it's.
So what you're saying is if it's only an interface with no other things, then it's a wrapper. Otherwise, like Magic School, HubSpot AI, all those are purpose-built.
Most likely. I don't know. I haven't used those specifically, but most likely they are. They have specific tooling built in. Yeah, they like have specific tooling built into an agent stack that allows them to do certain things that, for instance, a regular AI model can just say, oh, you should now go do this, or this is how you do this. It can actually execute those things, and it can actually like check its own work.
So maybe before you go.
No, go ahead.
So when you're trying to check ChatGPT, you basically just have a wall of text going back and forth, right? Just a blob of text, and that text can include your system prompt, right? But at the end of the day, there's a context window, which is a wall of text going back and forth that's reasoning on that. And if you put a UI in front of that, you're wrapping it. At the end of the day, no matter how fancy.
Yeah.
The tool architecture, you take the original prompt or the data set and you break it up into a separate chain of thought, and then you hard code the order of steps that might go to an LLM or to a custom model or to your own regex or code or to a database, and the agent framework is orchestrating it through this entire process. Makes sense? It's not just a wall of text going back and forth.
Oh yeah, that makes perfect sense.
So
It's
that's
just
the
in my
difference. That's the
world.
difference.
And in the VC world and startup world, this is generally still called a wrapper. Yes, it's very smart. It uses different models, all those things, but it's technically still a wrapper.
Well, so my startup, we compete with people who like wrap stuff, and it's like you just slap a word on top of it, and you call it whatever, and it's just an API call behind the scenes, right?
Yeah.
It's very different than that, I think. Yeah.
Okay, no, thanks.
Anyway, yeah. So if it doesn't matter when it's wrong, probably a wrapper, which I think we've now established. The other question to ask yourself is who actually built this? If it's just some random person with no experience in the field that it's trying to solve a problem in, it probably is not going to be very good. It might be really flashy, it might look good, but unless somebody who actually knows the field, knows the problems, has like scars from making mistakes, not always physical scars, obviously, but they're probably not going to know what it needs to do. And so it probably won't do what it is supposed to do. And the third question to ask yourself is this an actual task that it's designed around? Is this specifically doing a thing, and is it doing it really well, and is it doing it correctly and in a like defined manner, or is it just a chat box? And yes, a task could just be a wrapper, but if you answer the other two questions as it's somebody with domain expertise and it matters when it's wrong, if the chat box is genuinely the right thing, okay, valid. Most of the time it's not, though. So those three things essentially kind of lead into the idea that wrappers get commoditized. There are a bunch of startups that post on LinkedIn or Twitter or whatever oh, Claude just got this update, now my startup is dead because it has that feature. If they can launch a feature in a week that kills your startup, you have a wrapper. So purpose-built systems that are designed around specific jobs, specific tasks, that becomes infrastructure, and that's going to last in 10 years or 5 years. Nobody, in 10 years is impossible to predict, but yeah. So bottom line is that AI is a medium, and actually understanding the domain and the problem is something that's durable and scalable and like valuable. Thanks, that's it. Yeah.
Can you get to purpose-built with a closed source platform, or do you have to start with an open source?
No, you can do it either way. You can start with open source or closed source and have a purpose-built system. Yeah. Marcus was asking about like training our own models. Some companies do decide to train models. The economics behind that are very challenging, especially with how rapidly models improve and are released. For example, Cursor, the $30 billion AI coding startup, they trained their own model, but they just took this open source model, they fine-tuned it, according to them, very heavily, and they released that as their own model. It's misleading at best. But the economics behind training a dedicated model are so challenging. I mean, that's why OpenAI and Anthropic raise $30 billion, $100 billion to build out AI data centers and infrastructure and train and buy all the data and hire 2,000 engineers who know exactly what they're doing and the best mathematicians in the world. The economics kind of suck.
Where are you hosting right now?
Like what cloud? Google Cloud. Yeah. Yeah.
The reason why this discussion is kind of important is because you're totally right. You would not do purpose-trained AI. That's a bad idea. The problem with that is that wrappers or purpose-built are considered largely dead. VCs are not investing, and you know what I mean with that.
I do.
Since about last year, that conversation has been hot and burning, and they have not invested. In my mind, it hasn't come around, especially since the latest frontier models dropped, which have just an insane quality, make it easier and easier. So I've been following this with great interest because you're clearly trying to build mode after mode after mode, which makes a lot of sense. In your mind, will you be selling to a company? The acid test that I know is, will you be selling to a company that has a domain expert who also is well versed with AI tool usage? Because this will sell to someone who is deathly afraid of AI and has no idea how to even start.
Mm-hmm.
Perfect use case, and I hope you have massive success in that space. But that will at one point go away because you're people who are training people up on being good at AI, good enough, and be able to use the big tools just perfectly well. What's your answer to this? How do you want to keep that mode? How do you convince someone who knows AI pretty well, knows how to prompt reasonably okay, knows how to use co-work and the more elaborate systems? How do you sell to them? I'm really curious about that. And I don't want to put you on the spot. I'm just really curious.
Yeah, I mean, in my specific case with QTex, the answer is sort of twofold. The weak answer is we're in a niche and it's not worth, even though Anthropic released that report saying engineering is heavily underutilizing AI tools, they're a general purpose model provider and it's not really worth them going after a $10 billion market or a $20 billion market because they're going after a $1 trillion market. Will they eventually want to eat everything? It's very possible. But the weak answer is it's niche. The hard answer is data flywheel. So as you get more people actually using your product, you get that data of usage and what went wrong and what went right, and you use that to essentially reinforce and refine the things that work and you fix the things that don't work. And so your system essentially has a really solid, really robust system behind it that's been refined over many, many iterations. And that is very hard and very expensive to reproduce, which is a more robust moat beyond just, oh, this is a niche that they're probably not interested in.
That's a fantastic answer. Thank you.
Yeah.
Yeah.
That was a great answer. And tapping on to that, how do you think of the business model you're currently providing with this evolving purposeful AI system you have? Can you give us some ideas on really how to think of that? Is it a value add to work with your company? Or how do you think about the
Yeah.
business model?
It is a value add. So I'll give you guys a concrete example of the actual ROI on this. For a company to design something right now, design a hardware product, on average, there are really large tails on the left and right of this, on average it takes 18 months and $5 million in the US. A respin, which is essentially if you make a mistake, you have to do a redesign, you have to remanufacture the prototypes, you've got to do all the testing. That's around $10,000 to $100,000 plus, depending on the product and the industry, plus minimum 3 weeks of delays. It could be 2 months, easily.
For people who don't know engineering, like, is that for a laptop or is that for a remote control?
NVIDIA, for example, spends on average $40,000 for if they're doing a redesign on one of their graphics cards during the initial design phase before they launch it. $40,000, and they have a lot of clout, so they can probably get expedited manufacturing. So it's probably 2 or 3 weeks of delays, but that still is enormous. And for a lot of companies, that's a death sentence. If you don't get it right, all of a sudden you're out of money and your customers are no longer interested because you don't have any reputation to rely on. Obviously, NVIDIA, they don't care. People will buy their chips even if they are a month late. But the economics of a respin or a redesign are literally, for a lot of companies, are we going to be able to launch this product or not? And from our perspective, let's an example we did the other day, a laptop, an entire laptop motherboard. We reviewed the design and found problems in it in, I think, 2 hours at a cost to the customer of around $50.
I'm not charging them. I'm not joking.
No, I know. I'm very aware. That's why I said pricing is hard. But yeah, I mean, that's the kind of ROI we're talking here, is that instead of spending $20,000 on a redesign and having 3 weeks of delays, your engineers now have a list of things that they can prioritize looking at that already did most of the checking for them, and now all of a sudden you can get your product out faster and beat your competitor market. Yeah.
And in this example, are you guys sort of running those through at the design stage, even before prototypes and everything are made?
Yep. Yeah, so we operate in hardware. There's the idea, architecture, schematic, layout, manufacture, in that order. So we operate at the schematic level, where before you go take your schematic and turn it into a layout, because layout takes a lot of time, we find the problems in that right now before it becomes not even an expensive respin, but an expensive process of layout and then a respin, and then you've basically lost minimum 2 or 3 months between layout and respin. They came in a few minutes ago and said, oh, we have 1 minute. Any last thoughts or questions?
So did you build this from scratch if it's not a wrapper?
Yeah.
How long is that? Is that really expensive?
We actually spent probably a year designing our database and building a database that works with the type of data that we interact with, because we're in a really weird area where the data is ugly. All data is beautiful, but this data is ugly. And so we spent pretty much a year on that, designing ways to reliably interact with that data, extract information from it, and build a database around it. And then our actual review tool, we launched with beta testers from the time of saying, we're going to build this, to we have a beta tester, a company beta testing it. It was just over a month. But we went hyper speed on that, 18-hour days for a month straight, which isn't actually that much when you think about it. But it was built on top of that previous year of research and a lot of other developments on our own domain expertise in the field. For example, myself, I've been designing electronics for over 10 years. My co-founder has been designing electronics for over 5 years. So we know what it needs to do and how it needs to do it. But yeah, anyway, I think we're out of time, so thanks, guys.